right? So what I told, just nothing is there, just I want to make it simple. First, basic experiment what we have done. It is out pin, otherwise we will open this simulate block. What will be, you have DS1104 block there. You can check here. DS1104. That you have master, slave, express and this. I will take any one, right? You can slave bit out, bit in. That means that pin has acted as in or out. And you can see PWM block, I told you PWM is ready-madely available. I can use this PWM, we'll see that also I will check. Only at present I just given a simple a bit out. One pin I want to observe, one signal I have given, digital signal, that has to be observed from that pin. In the simulation environment I have given these pulses with some whatever your values you can give randomly, you can design it, right? So that pulse I want to observe from this pin. In between data conversion will be there to match your data values. So it will be default, always you maintain your converter, right? So after your this is a simple MATLAB step, nothing is required for this one, like this will. You have built, you can build your, when you are building, it should be with the please change it to support a very okay. It will write its C code, its own, how DSP coding you are writing. Machine level coding it will write its own, but it's not optimized coding. What you are written, same thing I will write it in two codes. Two lines. Whatever the path I write 2 lines. Like 200 lines. Because it is a machine level language. So ultimately, we can check here what happened. If you observe here, configurations, it has generated SDF file. It has generated SDF file which is required. And also you can observe somewhere it will be written, it's a C program. It will write its file in C. .c file is also be generated. You can see it's whatever, we will check it. It will generate its finally outcome is it SDF file. It will run. You can see that pulse. LDD it is connected on. Where it will be, we are given output which means 1 C1. You can see IO1. So whatever you are, if you want to now if I change, it won't change because the connection between the MATLAB and it is gone. The program which is you have generated, it is dumped in the flash, it is running. Now to create the connection, I have to go to platform of control desk. Control desk environment I have to open. So for that I have to open this platform is disconnected. Now I have to go to control desk. I'll bring that variable. What is that pulse variable to here? I'll change the frequency so that we can observe what could be done. Right? So, and it is running now. During the runtime, we can change my variable by using your SDF file. by using your SDF. So we'll see it. We'll generate one new project. Suppose project some 4 or 5 something, you define a project and location, everything. You need to experiment 1, project for experiment 1. 1104 is your morning. He explained some physical stuff. Next, and here you have to download your SDF file, which is generated from this environment, right? So where it is, I have to check. This is at EDS1104 folder. E folder DS1104. So I'll go to E folder DS1104 folder. 25 926 something 923. You can see that time. This time is different. 25 to 2025 927. We run at 923. 923. SDF file is generated. That SDF file will select very recent one. Finish. Oh. So that variables brought to here. That variables. This project is connected. Experiment 1 to ex1.sdf file is brought to this. Now I have to access these variables. You can see the variable environment in the bottom. I have this environment x1.sdf. What is there in this SDF? You can see timer task 1, model root, what data type, pulse generator. Right? What is the pulse generator? This will be your values. All the names we have given in here, pulse generator, data convert, all will come to there. All are variables only, right? So pulse generator is my variable I want to change. I will select that. You can see the pulse generator. In that pulse generator, what is there? Out is there. Pulse generator output waveform will be there. Pulse generator period is there. Time period we have defined in the variable pulse generator. We have time period. We have phase delay. It might be, you can see what will be there inside of that time period, amplitude, pulse. All are variables only. That will be reflected at your environment. You can change that values, right? So now I will take any instrument to change it. Directly I cannot change it. I can take a numerical input as my instrument. For that, I will link my time period to that. Time period variable, what I have done, I took one instrument as to connect. What instrument I took it? Like a numerical input. Numerical input, I can enter the number so that I can change. Or gauge, change, knob, so many instruments are there. You can go. Time plotter, different instruments are there. You can generate your GUI, graphical user interface, how best you can do it, how best you are designer. Right? So you can design your GUI. We are very poor in design as electrical engineer. You can design your best GUIs and how beautifully electrical machines are, things you can design. Here I designed a numerical input instrument and I connected this variable to here. Now my period of pulse variable connected to that, I can change it. I can enter the value so that I can change that value. For that, what I have to do? First I have to go to online. First I have to connect to that. There I have to go to online. If I go to online, what could be the present value? It will be displayed. 2000 it is there. So I can increase my value to whatever the value, it will be increased. Your time period value will be, if you are keep on increasing, your value will be reflected on the output. Right? Real time, during the runtime, I am accessing that variable in the control desk area. That is the beauty. In other controllers, it is not possible. Once the program is done, over. MATLAB says how you are disconnected, that's it. If you want to change it again, you have to go to MATLAB again, I have to change it, and I have to build it, it has to dump again. That steps are not there yet. Only you take the control desk environment, any variable, change it, run the process. That is the advantage of this controller. Particularly some applications it is much important. In runtime I have to change it. I cannot come to 0. During the runtime I have to change the speed. From 1400 to 1500 I have to go. For 1400 to 1500 for going the speed I should not come to 0 again. And what I have to do? I have to run. Otherwise it is not possible. If you use other controller with MATLAB, I have to come to 0, I have to define it, and I have to go to 1500 again. Round number क्या आता है? That is the application. Depends on my application, it has to be done. So this is a very simple example I have shown. It will go to offline. When you are not required, you can measure your time plotter also. You can see your time output, what I am running. You can see your pulse. You can change what it is coming there. That also. You can change it. The value time period it will be drastically increases. I am increasing my time period. You can observe the change. Overall time period will increase. You can see during the run time. And similarly, your signal is also the same thing. This is very simple one example. Once you go, if you want to go to offline again, it will be disconnected. It won't be operated. So this is the simple one experiment. I want to go with another experiment. We'll see. Simple one more module. What is your module to see?
So if we go offline, it will take
No,
MATLAB value only?
MATLAB, no, this value, last value. It will work for last value, not MATLAB. Whatever you updated, last value will be saved. So this is your pulse earlier we have given, now sine wave. The sine wave compared with carrier wave comparison, and same thing outer. Your PWM pulse width modulation, how it will work. Compare your sine wave and pulse wave and you can do it. Run it and what will be bit C2. It will go until you run the next bit, it will be there. In the flash it will go. You can see here dot C file. It will write, it's a dot C file. First it will write it dot C file. Then with the variables it will generate it SDF file. Then it will work. Successful completion of Simulink will procedure complete. So now you can see which pin is working. Second, we are given intentionally second also. One earlier, now two. With the frequency, how much we have given your sine wave and the same you build it again. You call that SDF file. You change your sine wave frequency, you change your carrier wave frequency, whatever you want it, you can do it runtime and you can work out yours. Right? The same thing we have implemented. This is your exercise 2 and exercise 3. What exercise 3? This is the almost example we got here. That is the V by F control of your induction motor. We have V by F control. Voltage by frequency control. For induction motor control. I want to control this motor speed accordingly V by F value.